Hello, Bristol. Can everybody hear me? 1, 2, 1, 2. Oh, that's better. I'm Slim Shady. I'm the real Slim Shady. Yeah? Cool. Right. My name is Fred, and I'm here to talk about the name programming language. Has anybody here heard of name before you saw my talk? Yeah, about 3 or 4 or 5 people. Yeah, that's expected. It's a very underrated language, and hopefully by the end of the talk I'll be able to change your mind and raise your awareness about it. Before we start, I'd like to make a disclaimer. I'm not a name expert. I've started playing with the name 7 or 8 months ago. So if you ask me any difficult questions, I'll just look at the ceiling and ignore you basically at the end. So bear that in mind. Now, another disclaimer, I'm an opinionated developer. I've been doing this a long time. If you have a favorite language or framework, I'll be very likely insulting you in the next 40 minutes. You have been warned. I'd like to start with a little background about myself, because I think it will help put the talk into context and why I'm here talking to you about NIM. I've been a professional software developer for the last 20 years. Yes, I'm that old. I know I don't look it. I've used L'Oreal for Men cream. So any L'Oreal representatives, feel free to give me a bung afterwards, or not. And I started out as a C developer. Okay, normally when I say that people throw things at me, you're a good audience. And I spent the first 12 years of my career doing C and C++. And it made me feel very much like that. Of course, at the time, I didn't know anything better. That was all I knew, really. I thought that developing code meant frustration and fighting the language, fighting the compiler, and all these nice things that we all love and hate. Then around the 2004-2005 period, I started getting into web development. I discovered ASP, Active Server Pages. Everybody here know ASP? Yeah? Now, I'm not talking about ASP.NET. I'm talking about the original ASP. Yeah? What they call classic ASP. Now, you hear classic ASP, and you think, oh, it's probably something like that. Now, in reality, it was more like that. Horrible, horrible stuff. And but it made me get into web development, and it made me learn some JavaScript. Or actually, I learned some VBScript as well. Does anybody here remember VBScript? Yeah? Yeah, do you still wake up screaming? Yeah, me too. Horrible stuff. But yeah, so it got me started anyway. And then I did Java for a couple of years. This is a photo of me when I first started doing Java. This is a photo of me when I finished doing Java. I was a bitter old man. I was frustrated with coding. I didn't have any joy in programming. And yeah, I was really, really despondent. And at that time, I discovered a language called Ruby. And I discovered I can actually be very productive with my code and knock things up in a few days instead of weeks, and also have some very elegant and code. So coding became a pleasant experience for me once more. And, you know, Ruby's great. I mean, it made me feel like that. Like all my birthdays and Christmas just to come at once. And I use Ruby to this day. I'm an independent Ruby consultant and developer. And with Ruby, I can actually write some really elegant code like that. I can write some expressive code like this. But I can write some powerful code as well, like that. So I can hear you thinking, because I'm a bit of a telepath, if he likes Ruby so much, why is he standing here talking to us about NIM? I'll tell you why. As I've said, I'm a contractor, independent freelancer. I get hired by people to deal with specific problems. And they hire me for 3 or 6 months or whatever to solve a specific issue. Now, I use Ruby, and 80% of the time I can solve the issue in an efficient, productive, and pleasant manner, which is great. 20% of the time I can't. And the reason I can't, because the issue involves one of these 3 things here: high performance requirements, concurrency, or parallelism. Now, are we all familiar with the difference between parallelism and concurrency? Yeah, concurrency is basically the ability to run code simultaneously without any interference or side effects, okay? And if you've got such a requirement, your best bet is to use a functional language, something like Elixir or Clojure or Scala, because functional languages lend themselves, due to the nature, to parallel programming. So that's your best bet, really. Now, concurrency performance, dynamic languages like Ruby or Python or PHP or JavaScript lack seriously in performance and concurrency. Most of them run on a single thread anyway, so we can't have real multi-threading. Now, I know we have in Python and Ruby, we have threads, but they're not real threads, they're virtual threads, yeah, they're green threads. What we can do, if we want to perform some concurrency, we can actually use a performant and concurrent platform, like the JVM, or if you come from a PHP background, the HHVM. And these are highly performant platforms, and they give you true multi-threading, they give you true threads. So we can actually port our Ruby or Python code onto JRuby or Jython on the JVM, and we've got performance and multi-threading. But it's not an easy decision, you know, we've got to change the platform. We've got to think about compatibility between the versions. We have to think about changing our design and architecture. So it's not something we would do lightly. Yeah? So a lot of us, if we want to perform some concurrency, fall back to the good old solution. We write code in C or C++. Now, most dynamic languages like Ruby, Python are written in C themselves and make it fairly easy, very straightforward to call C code from them, either through an FFI, a foreign function interface, or directly through an extension of the language. So, for example, in the Ruby world, we can actually write C code as a Ruby extension and call it as we would call Ruby code. So, again, I can hear you thinking, well, what's wrong with that? There's one thing that's wrong with that. It's C. Have we got many C developers in here? Objective-C, C++? Yeah, you have my sympathies. Yeah, I mean, I've done C for a long time. C and the C language of C family of languages is horrible. We have a horrible syntax. We have C is loosely typed. C++ is strictly typed, but it's got a horrible type system. And of course, and don't forget, they're not safe. We've got to manage our own memory. So we've got allocated memory. If we don't free the memory, our program goes boom. Okay? So it's not a pleasant experience writing C and C++ code. Don't take my word for it. Take the word of one of the creators of C++, Straustrup. So for the last 2 or 3 years, I've been looking at new system-level languages. So I've been looking at languages that will allow me to write low-level code that's performant, concurrent, but it's also safe as well. And my requirements were, obviously, safety. I don't want to manage memory all the time unless I really have to. Portability. I want to run my code anywhere. Obviously, performance. But I also wanted to be expressive and elegant. And that's what my Ruby experience taught me. You write expressive code is code that you like writing. It makes it easy to write. The code is elegant, it's easy to read. So that's very, very important to me. So the languages I've been looking at for the last 2 or 3 years now is, I started with 2 languages. First, I looked at Rust. Yeah, everybody heard of Rust. It's a language developed by the Mozilla Foundation, or backed by the Mozilla Foundation. And I had to look at Go as well, and Go is backed by Google. And then accidentally, about 8 or 9 months ago, I came across in a forum someone talking about Nim. And I had to look at Nim, and I just stopped reading about Rust and Go, and I started playing with Nim ever since. Allow me to introduce you to Nim. Okay, this is a very simple Hello World sample in Nim. Now, as you can see, we can just say hello world in a very simple manner. We don't have to import any libraries. We don't have to specify storage specifiers like static, etc. We don't have to call any external libraries like system. All this horrible crap that we've got to do in Java and C# and C++. We don't have to do it. This is just bureaucracy. I hate languages like that, languages that put obstacles in your way. They get in your way and they don't let you do what you want to do. And I've had enough of this. I've given up on these, and I don't want to write hello world with anything more than that. Now, Nim is a statically typed language. It's a compile language. So let's go and compile our program here. Okay, can everybody see that? Now, here's a catch with nim, which I think is a stroke of genius. Nim compiles into C, and then it builds the C code into binary. So what we're doing here, we're calling the nim compiler. We say, build me some C code, and use the GCC compiler, the GNU C compiler. Now, I use the GCC because I run on Linux. If I was running CLang, all I would have to do, call the CLang compiler. If I was on Windows, I would do that. Yeah? And I can choose whatever compiler I like. And let's go and run this. And as you can see, the compiler gave me a few hints about what it's doing, and it successfully compiled and built my hello world. Let's go back into our code now. And this is our original hello world code. And as you can see here, I don't know if you can see this on the left-hand side. Now, nim has added quite a few files and folders. We have a nim cache folder. If we open that, we can see that nim has generated C code for us. Okay? Now, I know it's horrible, and I know it's very, very large for a hello world program, but what nim does, it actually puts all the dependencies within one single file. So we don't have any external dependencies to install when we run the code on a different system. Now, the other thing that nim has done is it has this hello file here. As you can see, it's a binary file. So we can go ahead and execute this. So I can run, and this is hello world. Okay? Now, if I wanted to build a C++ code, produce it from nim, I could just do this. And again, nim goes and builds C++ code and builds a binary from the C++ code. And now if you go back into the nim cache folder, you can see that it actually built C++ code. Okay? So I can sit here on my system and choose whatever compiler, whatever version of C I want, and generate code that runs on it. What if I want to run this on my Mac? Well, one solution would be to take my Mac, install the nim compiler on it, and build my code there. Another solution, though, would be this. Let me find it so I don't have to type it again. Bear with me just one sec. There we are. Okay, check this out. What I'm doing here, I'm telling nim, so let me just clear this and try again. What I'm doing here, I'm telling nim to generate Objective-C code. I'm telling it to target a 64-bit platform and target the Mac OS X operating system. I'm telling it to compile only and to generate a script for me. And I'll show you what this does. If we go back into our editor, now we can see that nim has generated Objective-C code. At the same time, he has given us a build script, a shell script. So I can now take the shell script, take my Objective-C code, copy it on my Mac, and run my code on my Mac. So I've got true cross-platform compilation. Yeah, I can sit here on my Linux laptop and write code that runs anywhere, on Windows, on Linux, on Mac. That's true write once, run anywhere. You know what Java promised to do and failed miserably, basically. But the magic doesn't stop here. Watch this. No. Bear with me just one second. I hate live demos. I can actually generate JavaScript from nim. Yeah, you're blinking. I can say it again. I can generate JavaScript from nim. Okay? It's successful. Go back into our editor. And you can see here, I've got hello.js. Now, there's a reason this is a huge JavaScript file. That's just being sadist. Well, I don't know, just that. But actually, again, it's a dependency thing. Yeah, they have all the dependencies we need to run our code within the single file. So we can run this file anywhere without having to install any external dependencies, right? And if you don't believe me, I can actually go ahead and run my call Node.js and run my hello. Oops. And this is hello world from Node.js, yeah? This is pure JavaScript. And how cool is that? You know, this is true isomorphic programming, yeah? We can write one language that generates code for different platforms, client and server side. So, nim is truly portable. We can write code in C, C++, Objective-C, JavaScript. So that means we can interface with different systems, yeah? Because we can interface with jQuery and all these other systems that are running in C or C++, etc. It's not only portable, it's also interoperable. It makes it easy to talk, to communicate with other languages. So we just saw how we can create C or JavaScript code. We can do it the other way around. It makes it very easy to call JavaScript code within our nim code, or to call C and C++ code from our nim code. It also comes with a utility called C2nim. This allows you to take a C file and create nim code from it, which is very useful if we have legacy code running around in a system that we want to transform into a modern language. Now, nim was created, it started as a one-man project in 2005 by a German developer called Andreas Rumpf. Around the start of this decade, it started getting some mindshare. So some people were actually started contributing to it, and it became a bit bigger. And to this day, it's community driven by volunteers. And I stress the word volunteers because it's driven by people who just like take time off the work to contribute. It's not backed by a big corporation like Mozilla or Google at this point in time anyway. Nim is an imperative language, so it means that you write statements in terms of do X, do Y, do Z. And because it's imperative, it doesn't impose any paradigm on us, it means it's multi-paradigm. And as you shall see in a minute, we can use nim to write object-oriented code or functional style code. Now, nim is still immature. It hasn't reached version 1 yet. I know that Andreas is working on it, and there's a plan to get version 1 by 2017. Fingers crossed. Okay, this is how we define variables in nim. We can use the let keyword or the var keyword. Now, nim is a strictly typed language, which means that we have to declare the type of the variables when we define them. So as you can see in the first example here, we've got a variable called a, and we declare it as a 32-bit integer. We can also declare it using a compiler hint, as we do in the case of b. We've got 42 backtick i32. If we don't declare variables, then nim will try to infer the types. So in the case of c, nim will infer this is a 32-bit integer. So it's got type inference. Now, any variable we declare or we define with a let keyword is immutable. It means we can't change it. If you want to change a variable, we've got to use a var keyword. Just one thing you might have noticed here is that nim is white space significant. So, for example, here we have a let statement. Within the let statement, we declare 3 variables, one after the other. We don't use any delimiters. We don't have curly brackets. We don't have a do end blocks or anything like that. We use a white space to delimit the start and the end of a code block, basically. Just like Python. If you're familiar with Python, this will look very familiar to you, actually. Okay, that's where the good stuff begins now. Any variable we create with a let or var keyword will be collected, will be removed from memory by the garbage collector when it stops being used. So nim has a garbage collection facility, garbage collector. It's a non-tracing GC. There's currently a flame war between tracing and non-tracing garbage collector. I'm not going to go into the details, but I'll just say that nim is using a non-tracing garbage collector. But the catch here, and it's a beautiful thing, we can customize it. We can tailor it to our needs. So we can actually set the interval for which the garbage collector runs. So we can say run no more than 100 milliseconds at a time. We can set the frequency. So we can tell it to run every, I don't know, a few seconds or whatever. And that allows us to actually create soft real-time code, like games, for example, yeah? Where we need to control exactly how much time we spend on whatever action we're doing. Now, if we want hard real-time systems, we can actually turn the garbage collector off. We can disable it. So that means that we can actually write embedded code, any kind of mission-critical, performance-critical application, we can write it with NIM. Now, the catch, if you turn the garbage collector off, we don't get the memory cleanup, yeah? So we have unsafe code. Now, that means we have to manage our own memory using malloc and free type of functions, just like we do in C, C++. Yeah? That's the price we pay for turning off the garbage collector. But this is a unique feature. I mean, I haven't seen it in any other language. You can modify the garbage collector to whatever we're building, really. That means we can use NIM for high-level applications, and we can use it for embedded systems, for low-level applications. So it's well, like Dr. House says, it's pretty neat, It's a pretty cool thing. Now, functions are at the core of NIM. Very, very important. Now, the way we declare functions is with the proc keyword. As you can see here, we've got a function called positive or negative, and we pass some arguments, and because NIM is strictly typed, we've got to declare the types of the arguments here, and we've got to declare the type of the return value. Now, one thing to notice here is that every statement in NIM is an expression, which means that every statement is evaluated, which means that we can assign a statement to a variable, as we do here. We assign the case statement to the result variable. Now, those of you who haven't fallen asleep already might have noticed that we have a result variable here that we haven't defined or declared anyway, yeah? So you can tell yourself what's going on here. What's going on here is that NIM, with every function, gives you an implicit return variable called result. If we don't have a return expression within, a return statement within our function, then NIM will return what's in the result variable. Okay? So that means that we could write this function with an explicit return statement, and it will have the same effect. If the return isn't there, and there's a result variable assigned, it will return the result. If the return, as long as there's something in the result, as long as the result is not nil. If we don't have a return statement, and we don't have a result variable assigned, then NIM by default will return the last evaluated statement. So that means we can write a function like that, and it will have exactly the same effect. It will return the case statement. Okay, so there are three different ways to return values from a function. Now, you're going to love that, right? That's a unique feature. I haven't seen it anywhere else apart from NIM. NIM uses style-agnostic function calls. Now, earlier in the previous slide, we created a function called positive or negative, camel case. We can call it in the same way that we created it, or we can call it with snake case. NIM doesn't mind. NIM will resolve it and call the right function. Now, some people love this, like me. Some people hate it. I can see why, but to me this is a sign of a language that gets out of your way, that allows you to express yourself in the way you want. It doesn't put any obstacles in your way. And I just love that. It's basically NIM says, look here, I know you're trying to call a positive or negative function. Yeah, you might have a snake case or camel case. That's the way you roll. I don't care. I'm going to call it anyway. Sweet. Other thing that NIM does, it uses universal function call. Now, if you've done any Rust, you might have heard about that. It will also be in the new C++ standard next year, hopefully. But all it is instead of calling a function in the usual way, as in function name, parenthesis, argument list, we can take the first argument out of the list and put it before the function. So we have a variable called z here. So we could call positive or negative parenthesis z, or we could do z dot positive or negative. And of course, we could do the same thing in snake case as well. Doesn't matter. Yeah. Now, don't be confused. This is not a method call. Yeah. This is not object orientation. This is just an elegant way of calling functions with the arguments out of the function. That's all it is. Now, we can overload a function in the usual way, in the primitive way, where we have 3 different functions with different argument types. But nim allows us to do it in one fell swoop. So we can specify an argument, and we say it can be an integer, a float, or a string. And we can pass any of these types, and nim doesn't mind. And we can do the same thing actually using generics. NIM's got a very powerful generics mechanism, much more powerful than Java or C++. Unfortunately, I don't have the time to go into it, otherwise I would. But we can do something like that. We can tell NIM, hey, we're going to pass you an argument. At the time of writing, I don't know what the type will be, but just go ahead and echo it anyway. And NIM, we can pass any type, and NIM will go ahead and echo it if it can. Right. That's a very important feature the many languages have. Functions are first-class citizens in NIM. That means we can grab a function by the ear and check it into another function as an argument, or we can assign it to a variable. This is very powerful stuff. If your language doesn't support functions as first-class citizens, learn a new language, honestly. What we can do in NIM, we can have a sequence here, powers of 2 sequence, and we have a method in the segutils module called filter. Now, filter takes 2 arguments, a sequence and a filtering function. Now, because of the uniform function call that we talked about earlier, we can take the filter out of the argument list and put it in, we can take the sequence out of the argument list and put it in front of the function, yeah? And then we can just pass an anonymous function as a second argument. So what we're doing here, we're actually defining a filtering function on the fly, on the go. Now, if you don't like the proc syntax for the function, NIM gives us an alternative syntax. It's the do arrow syntax. So these 2 calls do exactly the same thing. The second call is much more elegant, much more Ruby-like, and I prefer it myself, but it's up to you. Again, NIM is all about choice and elegance. Okay, modules. Each file in NIM is a module by default, implicitly. All the variables and functions we define within the file, the module, are visible, got scope, only within the same file, the same module. Unless they are postfixed by star. So in this case, we have a file called person. We define 2 variables, color and age, and we can import a person into a second file, and we can access the color variable because it got the star after it, but we can't access the age because it's scoped only to our person module, or person file. That's very much like Python again, so if you do Python, you'd be very familiar with this. Now, as well as the primitive types, NIM gives us a number of structure types. Arrays, sequences, tuples, sets, and objects. And objects allows us to do some object-oriented style programming. Now check this out. Now object gives us a type hierarchy, yeah? A class hierarchy effectively. And the top object is called root obj, rather unimaginatively. I mean, I would have called it top cat or something, but they call it root obj. And what we can do, we can actually create a new type called animal that's based on root object, and we can define methods for it. Now, a method is just syntactic sugar for function, yeah, for proc. And as you can see, we need to actually specify the type for which this function, this method, applies. But what it does, we can actually inherit from animal. We have a dog and a cat, and we can see we have a basic inheritance plane here. Because we have a cat type, we define a speak method, but we don't define a age method for the cat, but we can still call age method on the cat because it will pick up the age implementation from the animal, yeah, from the parent type of the cat. And again, if you've done object-oriented code, you can read and write that, not a problem. If object-oriented code is not your cup of tea, that's not how you roll, you can do some functional style code with NIM. Now, NIM supports a pragma directive called no side effects. Programmer directives is what's in the curly brackets here, and it's just a way of passing information to the compiler from our code. And when we're telling here, we're telling the compiler, if a function has side effects, reject it. So in this case, we've got the echo statement, which is a side effect. If we try to compile that, computer says no. Now, if we remove the side effect, if we remove the echo statement, rather, we have no side effects, and the function will compile no problem. Now, because nim has an imperative style, doesn't impose any specific style on us, and because it has first-class functions, we can actually write some very functional style code. If you look at this example here, we have a full function. Now, other languages have full functions, some call them reduce. And basically, the full function takes two arguments, a sequence and a folding function, basically, an aggregate function. Now, again, uniform function call, we can take the first argument out of the argument list and call sequence.fold, and we can pass our aggregate function, which in this case is a minimum, and that will get us the minimum of the sequence, yeah? So -7. We can do the same with the max, okay? So this is very, very like kind of like Perl chainsaw kind of type of function calling, yeah? Very functional style. Right. So this is where it gets really interesting now, templates. Templates are very, very powerful tools in NIM. What a template does, it basically substitutes a node of the abstract syntax tree. Does everybody know what an abstract syntax tree is? Now, when you compile code, the compiler will do a lexicon analysis of the code. It will create some tokens. Then it will get the tokens and it will do a syntax analysis on them, what we call parsing, and will create a tree structure with its tokens. That's what we call the abstract syntax tree. And the beauty of it is we can actually manipulate this dynamically. And all a template does, it replaces whatever the template name is with whatever is in the body of the template. It's like a function, but it's much more powerful because we can do things like that. We can pass blocks of code in it. So what we're doing here, we're passing a variable called actions, an argument called actions. We declare it as untyped because at the time of compiling, we don't know what the type will be. When we call it, we pass some code. In this case, an echo statement, a message. So all the template will do, it will go and run this code as we told it to, yeah? It will replace the name of the template with the code in here, the code that we give it. So that means we can write stuff like that. A template that takes a file handle and a file path, and it takes a code block, what we call actions. And all it does, it opens the file, calls the code that we give it, and closes the file. So that means when we call it, we can do it like that, with file, and then 2 lines of code. These are the actions that we pass into it. So what we will do, it will open the file, write something in it, and then close the file. Yeah, so we don't have to worry about maintaining the file, yeah, opening and closing the file all the time. Again, this is very, very Ruby-like. You know, what we do in Ruby with the blocks, NIM does just as well with the code blocks. What doesn't stop here, we can actually directly access abstract syntax tree nodes with a template. So what we've got in the curly brackets here is a node that consists of an operator, star multiplication, and 2 operands, A and 2. So what we're saying here, we're saying, hey NIM, hey compiler, when you find a node that multiplies a variable by 2, go ahead and replace it with what we've got in here. So instead of multiplying something by 2, go and add the operand to itself. Why? Because it's more efficient, more performant. Addition than multiplication. So what we're doing here, we're actually changing the behavior of the language. I mean, if you think about it, it's a very powerful concept. Not the semantics of the language, just the behavior. Which is, in the words of Eric Hartman, pretty sweet. Okay, Now, this might blow your head, but I'll do it anyway. Macros are like templates on steroids, okay? Where a template can just expand and replace a node of the AST with another node, what's in the template body. Macros can actually actively manipulate the AST. Hopefully you'll see what I mean. Now, there's another unique feature in NIM. It's called compile time function execution, yeah? What that means, we can actually run code during compilation. I'll say one more time, we can execute code while we compile it. I know it takes some time to wrap your head around it. The only other language I know that does this is D, other than NIM. But what this allows us to do, it allows us to actually generate AST nodes at runtime. Compilation time. So instead of just with templates, we just substitute one node for another. With macros, we actually actively manipulate the AST. Let me give you an example. Okay. Don't worry about the details of the code here. All we have here, we've got a macro that actually takes a file that has NIM commands, NIM code in it. And it returns a statement. A statement is effectively an AST node. That's all it is. So when we run the macro here, we pass it a file with NIM statement, NIM code, and the macro will run this code during compilation. So what we have here, we have code that produces code. Yeah? This is the true definition of meta-programming. That's what we got here. Okay. Let me check my... Okay. Right, as we're running out of time, I need to mention threads because they're very powerful in NIM. You can do safe multi-threading in NIM. You can have safe concurrency. We don't need to do blocking and semaphores and all this things that we do in other languages. We can use channels in NIM. So we can start a thread. This is our main thread. We create a channel here, and we send a message to a channel. Then we create a new thread, and the new thread will pick up the message from the same channel and do something with it. We don't have to block. We don't have to wait. We don't have to synchronize. Nothing of this crap. It's just easy and safe. Okay. Right. I'll very quickly, I'm going to show you something. It's got 3 minutes, so I'll just very quickly show you that. Move into... okay. Let me open it in Sublime. Right. Okay. Now, we talked about the templates and macros, and how we can do meta-programming with them. And actually, a lot of people use that to create their own kind of like meta-languages. And there is a meta-language called Jestler, which is a web development framework in NIM. And I'll show you some code very quickly. This is NIM. You see this get as a template, yeah? So it's basically code that generates code. So we can pass it any kind of domain-specific commands as we do here, and it will run them, create NIM code, and run them in the background. Now, if you've done any Python development with Flask or Ruby with Sinatra, this will look very, very familiar to you. Okay, this is very high level. The beauty of it, we can have a client written in NIM. Yeah? So client written in NIM. Well, remember we can compile into JavaScript. So what we do, we get a server code, we compile it into C or C++ or whatever. We get a client code, we compile it into JavaScript, and we got a full end-to-end web framework, web application basically, yeah, from one single language. This is truly isomorphic programming at its best. Now, I'm not going to run it on the browser because we're out of time, but all it does, it just shows you your IP address and says it got a counter for the unique visitor number. Right, so why you should care about name if you don't know already, then I'll tell you why, because I know languages that have very high performance, languages that have high functionality and very elegant or very expressive, languages that are portable, and languages that are safe. But I haven't come across any language so far that has all of these elements to the extent that NIM has. And that's why you should care about it. Hopefully it will reach version 1 in 2017. If you want to learn more about NIM, you can go to the NIM website. There's a nice blog here that you can look up. And there's actually a book out that you can buy and learn NIM. That's what I've done. Okay, and thus my talk coming to an end. I'd like to thank you for your time, and I'll take questions.
Thank you. Questions for Fred? Who'd like to get us started? Down in the front row there. We'll come up to you next.
Debugging. Do you see that in NIM, or do you see that in the language that gets compiled from NIM?
That's a good question, actually. So far, I hadn't had to do any debugging, so I can't really tell. I know it's hard to believe, but I've seen other people in chat rooms and stuff that they basically use DBG and they debug the C code. I know there are people working in the NIM community to have a full NIM side debugger. I know that's on the works.
I wouldn't want to debug that code that it generates.
No, the C code, no. No, absolutely not. But as long as you can debug the NIM code, then it's very high level. I know the people are working on it, but I haven't used it yet. That's my answer.
I had a question. The gentleman in black at the top there, Ollie?
Yeah. It was kind of the same question.
Just grab the mic, because then we record your question as well, sir.
It's really the same question on debugging, but can you compile straight to assembler?
No, is the answer. You can do it through C.
Yeah, so if my NIM server doesn't work, I have to work out whether NIM is working, then look at some C which is unintelligible and work out if that's correct. And if that's correct, I then have to look at my AST and see if it's been overwritten.
Well, that's one way of doing it. The other way is the way we're doing it with dynamic languages for years now. We just put loads of debug write statements in the code. I mean, before the latest generation of Python and Ruby debuggers, or how we debug the code, we just use loads of write statements, and we try to figure out exactly where the fault occurs. And we can do the same thing with NIM.
If I'm debugging C, I tend to read the source code for starters.
Oh, yeah, I'm talking about the source code, the NIM source code, yeah, the NIM code.
Yeah.
We can actually put a statement and try to see where the statement occurs and if the error occurs before or after, and just so on and so forth. I know it's not pretty, but it's worked fine with dynamic languages for years now,
The other thing is, if you've got all your dependencies in a single header file, aren't your compile times going to be disastrous?
That's a good question. So far, my compile times have been excellent. Then again, I haven't run any big code bases so far. I don't know, possibly. But there's a GitHub page with benchmarks, and it mentions compile times as well, and they seem pretty reasonable compared to C or C++.
Okay, thanks.
It's not a big issue as far as I know.
Okay.
Thanks. A very interesting talk, thanks.
Question on the second row at the end there, please.
Reference testing, so like you've got RSpec for Ruby, what's the suite for NIM?
Currently none. That's a price you pay for having a language that hasn't reached a version 1 yet. Again, there is a project that is under development for a kind of RSpec Minitest kind of test suite. It's not mature yet, but again, as the language matures, all these things will come up. As a community builds around it, all these things will appear. That's what normally happens.
Had another question on the front row, and then to the...
Yeah.
Is there anything on like Rosetta code with any NIM examples?
There is, yes.
Yeah.
There is. I've checked it out.
And 3 rows up at the end. We'll have time for one more if anyone's got one.
So how is NIM getting access to? How is the NIM compiler getting access to like type information about code that's like running at its boundaries? For example, like the client you showed written in NIM was like calling functions on like document.window. Is that something that you'd have to provide like some sort of declaration file to see these are like the types of things that you could call and like the types it would accept and things like that?
No, I think that's what NIM does when it produces that huge JavaScript file. It puts everything in it, so you don't have to do anything yourself, anything external. I don't know exactly how it works, the mechanism behind it.
Sorry. So I meant like exactly how does it know what's going to be available, like for the, you know, using the client, the JavaScript client as an example, where is it getting that type information for like document? Is that like a library someone has already written that you, I know because you had like import document at the top, like.
I presume it's somewhere within the NIM code base, yeah, I presume so. Remember the disclaimer at the start of the talk?
Yeah.
So I'm like...
Reminds me of in the Kingdom of the Blind, the one-eyed man is king.
Pretty much.
Fred has one eye on NIM, the rest of us are the blind. We've got time for one more question, if there is one from the audience. If not, then we'll finish the morning. Oh, okay, just got in under the wire.
What about libraries? Can you like use JavaScript library for front-end code and then have like a Object-C library for the client code or something like that? And
In terms of JavaScript, you can, but you've got to hack it yourself.
oh,
So you're going to go to the JavaScript generated file and include, you know, your own sources, basically. If you want to do that, you can. NIM doesn't do it for you. You got to do it yourself. In terms of C++, you can call external libraries. It's very simple. You can call directly from the NIM code using a foreign function interface. There are lots of examples on the website of doing that. It's very easy. Yes, is the answer.
Okay, so we'll wind up the morning session there. Remind you again, please, go visit the exhibitor stands over lunch. Lunch is served out in the main foyer. Please do tweet Bristech 2016. Let's get that pushed up the rankings. And also have a look at the workshop schedule for this afternoon. Thanks very much for this morning. If you could join me thanking Fred in the usual way.